Okay, yesterday in our last class, we have shared a video clips describing work and energy. I hope that all of you must have understood well regarding the theme of this chapter. Now, I am going to explain in detail all those topics that you have gone through by viewing the video clips about these topics. So, as we know that in the previous chapter, or even you can say that in motion, you have seen that in order to set an object at rest into motion, you have to apply force. Even if you apply force, an object is not in motion or object is not getting displaced from its initial position, then what you say that your applied force do no work. Your applied force does no work because for work to be done, force must be applied and effect of force must be there in terms of displacement or in terms of whatever effect of force you have gone through. You have learned that force can produce following effect. Force can change shape and size of object. Force can change position of object. Force can change direction of motion of object. And force can change a speed of an object. So while you changing position of an object, you do what? And you can change position of object by applying force. By applying force, and even you can change shape and size of object. You can apply force. Only then you can change, and you can change direction of motion while you are riding a bicycle and you want to change the direction on the way. You have to apply force by your hand on the handle or a steering. And next, when you push a cycle with greater force, then speed of cycle get changed. If you apply force in the direction of motion of the cycle, the speed will get increased. And if you apply force in opposite direction of motion of cycle, the speed will get decreased. So you see here, in all the cases, work is being done here. So whatever effect a force can produce is converted into work done. So here we will discuss about work in terms of one of the effect of force that it can produce is change in position of object. When you apply a force on an object at rest, then position of object get changed if it get displaced. So changing in position is brought under the action of force, and hence work is said to be done by the applied force on the object. If you apply force and displacement is not there, that is change in position of object is not there, then work is said to be zero. That is, no work is said to be done in language of physics here. So let us try to understand You see here, this is the object, a box on the plane surface, and you now apply a force. Direction of force is in this direction, which makes an angle theta with the horizontal. But displacement is in this direction, in the horizontal direction. So you can see that force and displacement are not in the same direction, but they makes an angle theta with one angle. So in general case, how can you calculate amount of work to be done? So here, because of application of this force, this object get displaced through a displacement S. An object come to this point. You see here, for a force to do work, there must be movement in the direction of force. But here movement is not in the direction of force, but movement is in this direction. So what we have to do, we have to resolve this force into two components. One of the component will be in this direction and other one will be in this direction. So component in this direction will be parallel to the displacement. So we multiply the component parallel to displacement and displacement together. We get amount of work done by the force. You see here, component of the force this in this direction is F cos theta, because I hope that you must have gone through the trigonometric function sin theta and cos theta. If not, then I will explain it in later class. So right now try to understand, uh, in a right angle triangle, there are three basic trigonometric function and three other reciprocal of it. And these are called trigonometric function. First one is sine theta, sine function, and second one is cosine function, and third one is tangent function. And reciprocal of sine is cosic, and cos is sec, and that of tan is cot. So here we have to deal with the cos and sine. In a right triangle, if you find the ratio of two sides and included angle, then this ratio gives a relation. That relation is called trigonometric function. So ratio of base to hypotenuse gives a specific function that is called cosine function. That is cos theta equal to base of right angle triangle to hypotenuse of right angle triangle. So here this force is hypotenuse. You see here. And you draw a perpendicular here like this, and this becomes base. So you apply the formula base upon hypotenuse equal to cos theta. Therefore, base equal to hypotenuse into cos theta. Here hypotenuse is force F. So here component of force along this direction is F cos theta. Therefore, work done to displace this object through displacement S is just equal to product of displacement and component of force in the direction of displacement. Now, come to the point here. Work is said to be done when force acts on an object, and object is displaced in the direction of force. If object is not getting displaced, then no work is done. And work done on an object is just equal to the product of force applied on the object and displacement. So mathematically we can define work as work done is just equal to product of force and displacement in the direction of applied force or component of force in the direction of displacement. So here, if constant force is applied and force applied in the direction of displacement, then work equal to force into displacement, that is F into S, that is Fs. But here in this figure we see that uh, force and displacement are not in the same direction. In that case, we take one of the component of force parallel to the displacement, that is F cos theta in this direction, and F sin theta will be in this direction. So this component of force do no work because displacement and this component of force makes an angle of 90 degree with each other, so work done will be 0. But now the component F cos theta in this direction and this displacement are parallel to one another. So these two work. This force do work. So force component of force. Hello, is there any problem? Yes. A screen is visible to you or not?
Yes.
Okay. All right.
Yes.
Now, so we have learned that general mathematical formula for work to be done is just equal to product of force and displacement provided.
11. ये गिलास कहाँ है? तीन आदमी.
Okay, provided provided force applied must be in the direction of displacement. If force applied is not in the direction of displacement, then formula for work to be done will be one of the component of force, product of one of the component of force in the direction of displacement and displacement. So here you see force work equal to force into displacement, and SI unit of work is Newton meter. SI unit of force is Newton and SI unit of displacement is meter. So SI unit of work is Newton meter, and this Newton meter itself is called joule because uh, work has unit just equal to that of unit energy, that is energy having unit joule. And you know well that work and energy are the two aspects of the same things. If you do work, you invest energy, and to do work you require energy, and to produce energy you have to do work. So these two, energy and work, are the two aspects of the same things. And now suppose if F is 1 Newton, force is 1 Newton and displacement is 1 meter, then work done is said to be 1 Newton meter or 1 joule. Joule is abbreviated as capital J. And so 1 joule is the amount of that much work done when a force of 1 Newton displaces an object by a displacement of 1 meter, then work is said to be done as 1 joule. Now, another example, if force of 5 Newton acts on an object is displaced through a displacement of 2 meter in the direction of force, then work done is said to be 5 Newton, product of 5 Newton and 2 meter, that is 5 Newton into 2 meter equal to 10 Newton meter, and Newton meter itself is called joule. So 10 joule work is done. Now as we have already shared video clips regarding the work, so we all are familiar with the word work. We do a lot of work every day. We have discussed that even a single moment we cannot live without work. Every moment we do work. Your digestive system works, and that's why it breaks down the food gradient into the molecular form, and then energy is produced and that energy is absorbed by your body. So according to science, a work is said to be done only when force act on an object and which displace it or which cause the object to move. Only work is said to be done. If it is not so, then work is said to no work is said to be done. As for example, you apply a force on the wall or on a heavy vehicles like truck, and you are not able to push it, you are not able to move it. It means there is no displacement and hence no work is done. Although you apply force, you get tired, you get exhausted, still no work is done in according to principle of physics, because for work to be done, displacement must be there, and therefore the two conditions required to prove that a work is done. First condition is that one, a force should act on an object, and second one is the object must be displaced under subject or under action of applied force. And if any of the two condition is absent, no work is said to be done. You see here in the figure, and a sledge is there. A sledge on its own cannot move, therefore a pulling force is applied there. So if any one of the above condition does not exist, then work is not done. Work is a scalar quantity. It has no meaning if you correlate it with that direction. So work is a scalar quantity. It has only magnitude and no direction. And the unit SI unit of work is Newton meter, and this Newton meter itself is called joule, and joule is abbreviated as capital J. And now come to the point, work done by a constant force. First thing, when a constant force is applied, then how much work is done? Now try to understand here. Let a constant force F act on an object, and let object be displaced through a displacement S in the direction of applied force. Then work W is said to be done, and here we have to correlate mathematically. So we define work to be equal to the product of the force and displacement. Even you can say that equal to the force and displacement, because force and displacement are in the same direction here you see. So in this case, when force and displacement are in the same direction, then okay, then work done is just equal to product of force and displacement simply. For example, if 1 Newton of force and applied and object get displaced under action of this 1 Newton of force through a displacement of 1 meter, then work done by the force is just equal to 1 Newton meter or 1 joule. You see here work equal to force into displacement. Now, work done by constant force acting on an object is equal to the magnitude of force multiplied by the distance moved in the direction of force. Or even you can say that the it is equal to product of it is equal to the product of magnitude of force or component of displacement in the direction of force or component of force in the direction of displacement. If the force and displacement are in the same direction, then work done will be equal to the product of force and displacement. That is, work done will be positive. So you see here, and if the force acting on the object in opposite direction to that of the displacement, then work done will be negative. So here we have learned the condition for the work done to be positive and negative, and work done by the gas, as you see in the motor engine, or you see that there is a gas produced inside the chamber of engine, and that gas produced has pressure that is exerted on the piston, and that's why piston starts moving. As a result, vehicles move forward. So here also, yes, is there any problem? Okay, so here also a gas molecule exert a pressure. This is the a setup indicating piston. You see a cylindrical setup, and this is the piston that can move ups and down, and this is the gas. So when there is expansion in gas, this gas will exert a pressure on this piston, and piston will move up, and when pressure decreases, this will move down. In this way, gas will move the piston up and down. So a cyclic movement will be there, and as a result, external system connected to this piston will starts moving. So first of all, let us take here. We know well that pressure equal to force per unit area, that is force upon area. So area of this piston is capital A, and pressure exerted by this piston is P. So pressure equal to force upon area, that is P equal to F upon A. Therefore F equal to P into A, and hence work done equal to force into displacement, because if piston get displaced through a displacement S, so W equal to F into S, and in place of F we place P into A, that is product of pressure and area. And so area into displacement is just equal to volume. So change in volume. Therefore, work can be expressed as a product of pressure and change in volume of gas. So here we have another example or expression for work done, and that is the work done by gas or work done on the gas system. So, okay, now, so we have learned expression for work to done as product of force and displacement, and another expression for work done. in case of gaseous system is just equal to product of pressure and change in volume. So as you inhale air during breathing, a volume of your lung system increases, and when you breathe out, volume decreases. Even in that case, you do work. So, uh, some example of works situation that you have to realize that somewhere work is said to be done and other in other situation work is said work no work is said to be done. So here, suppose Arya pushed a large piece of rock and the rock moved through a distance. In this case, work is done because Arya pushes the rock and rock because of pushing moves ahead. So work is done. On the other hand, Ashish tried to push a refrigerator in his room, but it did not move. So work done by Ashish is zero. No work is done by Ashish because refrigerator is not moving. Now similarly, come here, Akhil pulled a box and the table moved through a distance. So work done by Akhil is non-zero. It means Akhil do work. Akhil does work, and Anandu tried to lift a bench lying on the floor, but the bench did not move. It means work done by Anandu is zero and no work is done by Anandu. Now, next situation is Megha kicked a football and the ball moved a little. It means Megha does work. So these are the various situations where we have seen that work is done and no work is done. Similarly, you can imagine various situations where whether work is done or not. So as you see that work is done because the applied force displaces the object or and object moves. So in this situation, work is done. But here you see work is not done because the applied force could not move the object or cause the displacement. So this is the situation of no work done, and this is the situation for work done. And similarly, uh, motorcycle or any motor vehicles has engine, and in the interior of engine in the gas chamber where petrol or diesel get converted into gas, and that gas produce uh, that get gas expand. As a result, it exert pressure on the piston and piston starts moving. So even then work is done. So when gas expands, work done by the gas. And when gas contracts, then work is done on the gas. So expansion of the gas means work done by the gas. That means positive work is done. And when contraction is there, that is decrease in volume of the gas, then work done said to be negative, and work is done on the system of gas. So only 2 minutes left. Let us move on. The work done by force may be positive or negative. Here, types of work to be done. The work done by force is positive if the force and displacement are in the same direction, and the work done by the force is negative if the force and displacement are in opposite direction. Work done by the force is zero. This is said to be zero work done. So there are three types of work done. One is positive work done, second one is negative work done, third one is zero work done. So work done by the force is zero if there is no displacement. For the zero work done, there are various conditions available. But for the positive and negative work done, only one condition is there, that if force is and displacement is in the same direction, then work done said to be positive. And on the contrary, if the force is opposite to the displacement, then work is done negative. And here, but for the work done to be zero, there are several conditions. First one is that work done by the force is zero if there is no displacement, and work done by the force is zero if the force is perpendicular to the displacement, and work done by the force is zero when no force is acting on the object. So when we lift an object and moves upwards in the direction of force, here the work done is positive, but there is a gravitational force acting downwards on the object. So work done by the force of gravity is here negative at the same time. Now another example, a porter lifts a luggage of 15 kg from the ground and puts it on his head 1.5 meter above the ground. Then calculate the work done by him on the luggage. How much work done by the porter on the luggage? You know that luggage has 15 kg weight, 15 kg mass. So we have to calculate the weight of the luggage, and then minimum force applied by the porter must be equal to that of the weight of the luggage. So you see here, mass of luggage is 15 kg and displacement is 1.5 meter, and acceleration due to gravity is 10 meters per second square. So you know that from Newton's second law of motion, force equal to mass into acceleration. So 15 into 10 equal to 150 Newton force is to be applied by the porter on the luggage. Now we have calculated force. So displacement is 1.5 meter. Now we have to multiply force and displacement together, and you will get the situation here. Force is 1.5 meter, okay, and so here this is equal to 225 kg meter per second. 225 kg meter per second, and this is equal to 225 Newton. Here kg meter per second square, so here a 225 meter, a Newton meter, and Newton meter itself is called joule. So this is 225 joule. So far we have discussed about work, and today I will share, in the next class I will discuss about energy and various forms of energy, as we have discussed a lot about the force and various types of force. That's all for today. Okay,
Thank you, sir.
thank you. And listen, I will share a complete digital notes on the chapter motion. First chapters, I have not shared any digital notes over that, so you must view it. Just after finishing this class, I'm going to share that digital notes. That will be helpful for you. And if
सर 11 बजे से
yes,
हिस्ट्री एसएसटी क्लास होता है, इसलिए हम लोग ज्वाइन भी नहीं कर पाते हैं।
SST class,
सर 11 बजे से होता है, इसलिए हम लोग ज्वाइन नहीं कर पाते हैं।
और आप कौन सी क्लास 9 हो? 9E?
यस सर।
ओके ओके, आपका 10:30 बजे से क्लास है ना? ओके ओके। ऐसा करेंगे कि नेक्स्ट क्लास में आपको अरेंज कर देंगे, ठीक है? और शेड्यूल टाइम पर होगा। एक्चुअली है क्या कि 9D 9B और 9E सबका तो एक ही टॉपिक पर डिस्कशन चल रहा होता है, इसलिए ओके, आई एम गोइंग टू शेयर डिजिटल नोट्स